Today I'm going to be simplifying radicals with complex numbers and solving quadratics that have complex solutions. This is page 51 in your notebook for spring 2020, and it's finishing page 51 that we did 2 weeks ago. It's Student Journal page 53 and 54. Okay, so from what we learned when we began page 51, we know that we cannot have this negative under the radical. So what we must do first is rewrite this as the square root of -1 times the square root of 49. Then we learned that the square root of -1 is I, the square root of 49 is 7, and I times 7 is 7i. Moving on to number 2, the square root of -4 is the square root of -1 times the square root of 4. And I may have done these problems already, but that's okay. I know I did not do 3 and 6, so it'll be a good review to see these again and then go over 3 and 6. Okay, so the square root of -1 is I, the square root of 4 is 2, I times 2 is 2i. For number 3, we would do the same thing, the square root of -1 times the square root of 45. I know the square root of -1 is I, but the square root of 45 is not a perfect square. But I want you to think about the factors of 45. 1 times 45, 3 times 15, 5 times 9. I think that's it. Are any of these a perfect square? One is, but I don't need that one. 45 is not, 3 is not, 15 is not, 5 is not, but 9 is. So I can rewrite the square root of 45 as the square root of 9 times the square root of 5. That's what I'll do. Then the square root of, I'll bring down my I, the square root of 9 is 3. The square root of 5 only has one factor, 1 times 5. This is a perfect square, but the square root of 1 is 1. It won't change any value over here. So we'll leave that as the square root of 5. And I times 3 times the square root of 5 is 3i square root of 5. Okay, let's move on to number 4. So for number 4, I already have a -2 out there. Keep it. The square root of -100, I break apart into the square root of -1 times the square root of 100. Bring down my -2. The square root of -1 is I. The square root of 100 is a perfect square, so that's 10. And -2 times I times 10 is -20i. For number 5, bring down my 6. Bring down my square root of -1. Bring down my square root of 121. Bring down 6. The square root of -1 is I. The square root of 121 is 11. 6 times I times 11 is 66i. Okay, moving on to number 6. Bring down my 5. Bring down square root of -1 and square root of 75. 5 times square root of -1 is I, and 75 is not a perfect square, so I need to think about the factors of 75. 1 times 75, it's not even, so it's not divisible by 2. 3 times 25. 5 times, is that 15? I think that's it. Okay, so as I look at those factors of 75, are any of these factors a perfect square? Yes, 25 is a perfect square. So I'll rewrite 75 as the square root of 25 times the square root of 3. Then I'll bring down my 5, bring down my I. The square root of 25 is 5. And 3, the only factors of 3 are 1 and 3. 3 is not a perfect square, so keep square root of 3. And 5 times I times 5 times the square root of 3 is 25I square root of 3. Okay, so that finishes those problems, and now we'll do 16, 17, and 18. Okay, when we do these, we are trying to get x alone. So like you've been doing for quite some time, we're going to subtract 25. We're going to divide by 5. Negative 25 divided by 5 is negative 5. If this were a linear equation, we'd be finished, but it's a quadratic. To finish solving a quadratic, you take the square root of both sides. Remember, when you're solving, the degree tells me how many solutions I'll have. The degree is 2, so I'll have 2 solutions, a positive solution and a negative solution. The square root of negative 5, I need to simplify like I did these problems up here. So I'll rewrite it as the square root of negative 1 times the square root of 5. The square root of negative 1 is I. 5, the only factors of 5 are 1 and 5. The square root of 1 is 1, so that wouldn't change the value out here. And the square root of 5 is a decimal, so we'd leave it that way. And that's my answer. I could leave it like this, or I could write this, no parentheses, negative I square root of 5, positive I square root of 5. Either way you write that is fine. Just don't put any parentheses around it. Okay, moving on to number 17. I'm going to add 10 to both sides. So x squared is going to equal negative 18 plus 10 is negative 8. I'm going to take the square root of both sides. Remember, it's a quadratic, so I'm going to have 2 solutions. The square root of negative 8, I need to take that negative out. Then I need to think about 8, the factors of 8. 1 times 8, 2 times 4. Are any of those numbers perfect squares? Yes, 4 is a perfect square. So x is going to equal plus or minus I times the square root of 4. I'm going to put my perfect square first, times the square root of 2. And I would have x equals plus or minus I times 2, because the square root of 4 is 2. Square root of 2, that's a prime number, so it can't be simplified anymore. And then to multiply I times 2, the best answer would be x equals plus or minus 2I square root of 2. You may stop here, or you may say your solutions are negative 2I square root of 2 and positive 2I square root of 2. And moving on to the last one, number 13. The first thing I'm going to do is subtract 4/3 x squared. Negative 1/3 x squared minus 4/3 x squared is going to be negative 5/3 x squared. I'm going to multiply both sides by negative 3 first. That'll get rid of the negative and get rid of the 3. So I'll have 5x squared equals negative 3/5. I'm going to divide by 5, but I'm going to write it like this over here. And then I'm going to have x squared equals negative 3/5 times, remember, division turns into multiplication of the reciprocal, times 1/5. I'm going to run out of space. I'll just have to flip my paper over. X squared is going to equal negative 3 times 1 is negative 3. 5 times 5 is 25. I'll flip my paper over. Then I'll take the square root of both sides. Remember, this is a quadratic. It has two solutions, a positive solution and a negative solution. I'm going to write the numerator and the denominator with a radical. This and this are the same thing. I'm going to simplify the numerator. 3's prime, but I can pull out that negative. I'll keep that square root of 25 for right now. And then I'm going to simplify all my radicals that can be simplified. So x equals plus or minus, the square root of negative 1 is I, times the square root of 3, the square root of 25 is 5. So there's your two solutions, or you may write them this way, negative I square root of 3 over 5, positive I square root of 3 over 5. And don't forget, never use parentheses around solutions, because when you use parentheses, it looks like a coordinate where you have an x and a y value, and that's not what you want unless you're solving a system of equations.